In this video we will teach you about sensors wiring to E-log. What will be described in this video about wiring to E-log can also be applicable to Alium module. When using sensors supplied by LSI LastM, the easiest way to learn about their wiring connection to the E-log terminal board is to use the report document generated by 3DOM program. Report can be made when the sensor's configuration is completed. Click on Report button to produce the document in Word format. This document contains also other information regarding the whole configuration. For each sensor, report explains which wire must be used and in which terminal input it must be connected. Same kind of information is also reported in the schematic drawing included inside each sensor box. Here is an example of the report document when the following sensors are connected to E-log. Relative humidity wires from the DMA 672.1 sensor, connected to analog inputs channel number 1. Temperature wires from the DMA 672.1 sensor, connected to analog inputs channel number 2. Take note that DMA 672.1 temperature and relative humidity sensor uses the actuator number 1 for its powering. Powering has been set 5 seconds before acquisition. Wind direction wires from the DNA 121 sensor, connected to input channel number 3. Wind speed wires from the DNA 121 sensor, connected to input channel number 9. DNA 121 wind sensor uses the actuator number 2 for its powering. Powering has been set as always on. DPA 154 pyranometer with microvol output, connected to input channel number 4. DQA 240.1 pressure sensor, connected to input channel number 5. DQA 240.1 uses the actuator number 3 for its powering. Powering has been set 20 seconds before acquisition. DQA 230.1 rain sensor, connected to input channel number 10. Now, following the wiring instructions reported in the report, we can start to connect the sensors. But attention! Before starting the physical wiring connection, remember to switch off the E-log data logger. You must be aware that the wire's color described in the report document reports the colors used by the old cable models, example old DWA505, and not the newer DWA505 suffix A model. The old cable and the newer cable models are different in some of their wiring colors. For example, if you read black color wire in the table, and you are using the DWA505 suffix A cable, you must consider the green color wire instead. Same for the blue wire of the old DWA505, which is now replaced by the gray wire in the new DWA505 suffix A cable. And the red wire of the old DWA505, which is now replaced by the pink wire in the new DWA505 suffix A cable. In the document is also described the correspondence between the old and the new colors for different cable types. Here, as example, is the wiring connection of the DMA 672.1 temperature and relative humidity sensor using the report instructions. We connect the white wire inside the terminal number 2, the shield wire inside the terminal number 3, the green wire in the terminal number 5, the gray wire in the terminal 6, then we connect the black wire in the terminal number 8, the purple wire in the terminal 9, the yellow wire in the terminal 10 and the orange wire in the terminal number 11. Here is the wiring connection of the DWA505 suffix A cable used by the DNA 121 wind speed and wind direction sensor. Same wiring if we are going to use DWA510A, 525A, 526A, 527A cables instead. We connect the pink wire, reported as red wire in the report, inside the terminal number 13, the yellow wire inside the terminal number 14, and a shortcut wire from terminal 14 to 15, the white wire in the terminal 16. Then we connect the brown wire in the terminal number 17, the shield yellow wire in the terminal 18, the green wire, reported as black wire in the report, in the terminal 24, and the gray wire, reported as blue in the report, in the terminal number 25. Now, in the following example we are going to connect, using a DWA505 suffix A cable, the DQC102 evaporation water level sensor, having 4 to 20 mA output, to the input number 8. We connect green wire, reported as black in the report, inside the terminal number 49, yellow wire and shield wires both inside terminal 51, and gray wire, reported as blue wire, inside 53. Then we need to place a shortcut wire between 50 and 54. Finally, we place the 50 ohms resistance unit between terminal 53 and terminal 54. Whenever the single-ended connection type is required, we need to set this connection type in the 3-dome program. For example, if we want to connect the two voltage signals from a DQA340 soil temperature and moisture sensor to the same E-log analog input number 1, we need to enter the DQA340 sensor in the configuration list. Then, we select the first measured parameter, select Edit and go to the acquired sensor label. Here we need to select single-ended channel A, in the analog input type item. Same operation for the second measured parameter, but for that, we need to select the same input number 1 and then we need to choose single-ended channel B. In this way two signals will be addressed to the same physical input number 1. About the wiring, in the report we can read that the white wire is connected to the terminal 2 of the input number 1, violet wire in the terminal 4, the gray wire in the terminal 3. Then, red wire to terminal 5, black wire to terminal 6 and pink wire to terminal 7. Finally, we need to place a shortcut wire between terminals 4D and terminal 6. This is because DQA340 sensor has galvanic separation between power and analog output signals. When finished, we suggest to double-check the solidity of each wire inside its terminal and the correctness of the wiring colors according to the report. Now it is possible to switch on the E-log and wait a few seconds to read the measuring instant values on its display. The delay of the reading is related to the acquisition time rate programmed for each sensor. If the values are not consistent, one possible additional check we may suggest is to measure, using a voltmeter, the signal output reaching the terminal. In this case you must remove the signal connector keeping the actuator terminal connected. In this way the sensor will be powered anyway by the data logger. On the voltmeter, we must read a proper signal value corresponding to the sensor measuring conditions.